exponential function. How many do I have on here? Number 6 is 2e to 2x. Number 7, 5e to 5x. Number 9, well, that didn't have an e. Number 8 had one. So, all right, here we go. What's the derivative cosine? Oh, here we go. SC, SC, S. Where are the negatives?
Third and fourth.
Third and fourth. If you go that way, you're differentiating. So what's the derivative of a positive cosine?
Negative sine.
Okay, here we go. Negative sine of, I'm gonna put there's my G. There's my G. I get to put G back in, right? There's G, put G back in. Let me describe what I just did. It's like I just did F prime, put G back in. Chain rule, right? But what else do I have to do? I did all that, now I have to multiply the derivative of this. And if you have to go off to the side to see what it is, and figure it out, go right ahead. What's the derivative of this? So this gets multiplied what? Right here. But we're not going to leave the answer like that. I think we should put this in front of the sign. And what's the negative times the negative?
Positive.
So there's the F prime of G. There's the G prime. And you can put G of X if you want to, G of X. And our final answer is positive e to the negative x times sine e to the negative.
You can also write divided by e to the power x to write.
That's right. He says you can write sine of e to the negative x divided by e to the x. Remember a negative exponent? You can bring it to the bottom. Oh, great job. Hey, on that note, here, try this guy. F was, I know everyone, I could use letters like H of T and G of T and all that. I'm just going to always use F of X. All right. What if F of X was sine? E to the negative x. Let's see how that answer was. I was true sine? Cosine. Put my G back. But don't forget the chain. Everyone, what's the derivative of all that?
Negative e to the power negative x.
Negative e to the negative x, as we just saw. But everyone, here's that work. We're talking about like, ooh, let's be careful with that. Sometimes you go off to the side that will form a chain rule. You gotta get a chain rule inside of a chain rule. Like we were saying, like an F of a G of an H.
Oh, could you explain how negative e to the negative x is the derivative of e to the negative x?
You bet. So the rule is, and this may help you, because e to 5x, e to the x squared, e to the x cubed, is different from those polynomials or monomials like x squared. We don't do power rule, do we? It's special. The derivative of y equal to e to the x with respect to x is e to the x, right? But every time it's just not an x, we got to apply chain rule. So let me say it again. The derivative of e to the x, e to the x, right? Really easy. But when it's not just e to the x, we got to apply what? Chain rule. So you might find this easier to write this. Make a little thing in your notes and say if you got something y equals e to the u, feel free to write this. The derivative will always be this. E to the u multiplied by u prime. That's chain rule. That's what's going on, where u is just what? A bunch of stuff. You just notice we always reproduce it. Because the derivative of e to the x is e to the x. So this is really what's going on. So look, if this was e to the 4x, find the derivative of e to the 4. E to the 4x times, what's the derivative of 4x? 4. But you notice now, you go, okay, what if I'm doing this? All right, reproduce e to the negative x, but times, what's the derivative of that negative x? Negative 1. Does that make sense? Feel free to think of it this way. Like say it's special, and I'm always going to think of this. That's what you do. every time with these e's. Yeah, what's the best way to write that answer? All right. Negative e to the negative x cosine of? Hey, these two are final exam type problems, right? Remember when you get to the final? Remember it's like what is it again? July 15th? Right, Kayla, you're just sitting in here taking this thing and you gotta, doing all these multiple choice problems. Not a bad thing, but sometimes an A, B, C, D, E all look alike, don't they? You have one of these, you know what I mean? A, cosine e to the negative x times e to the negative x. B, that answer. C, cosine e to the negative x times a negative 1. You follow me? And you get all, it starts causing that fear, right? An anxiety, like, oh, for crying out loud. But you just stop, you take it slow, you're like, I'm gonna figure this out, I'm gonna figure this out. Okay? Good deal.
The previous problem was sine of negative e. It's negative, how do you go from the two negatives to the positive?
Ah, right here. You see that one? And then here's the other one. Because this was a product of all these functions. So the negative times the negative made it positive. But this one only had what? Yep. And you know why we shouldn't leave it like this? And the answer, because sometimes that looks like a subtraction sign, doesn't it? It may look like you got cosine and minus that, and it isn't. Good deal? I know we're still rolling with chain rule. And we're gonna get into section 3.5 today. This is one section I never leave. I keep going with it and going with it. I get your questions on things. You have questions on these, you like to extend problems. I want to do another one of like these, what do you call it? Tangent lines. How many times have we done that? I know you did it on the last test, but we've done it at least 5 times now. Find the equation of the tangent line drawn to the curve, right? And that m is always representing the what? Derivative? So can we try one? Cool. The book has some, I got one here. All right.
I got a question. You're not going to give us
Sure.
any normal, right? Like find the normal. In the book they had some normal, so I was doing it last
Boy,
time.
that was a really good question. And we should talk about that. All right, here's a curve. Can I erase the other part? Are you sure? Did you get all this too? Good deal. Good deal. I'll leave my curve. Right here on what's a tangent? Maybe something like that. Tangent. Do you agree? Rough sketch of a tangent. Well, now the textbook starts talking about the normal line. That's a tangent line. And it is linear. A normal line is a line that goes to that same point at the curve, but it's doing what with the tangent line? Guess what the degrees are right there?
90.
90 degrees. So in just a definition, so you're aware of every time you want to practice a problem out of that textbook, and they say find the normal line, not the tangent line, but the normal line. Now you know something about slopes. So let's give an example of one. Let's say the slope of this tangent line right here was 2/3. Then what would have to be the slope of your normal line from your old algebra days? You did something with it. What'd you do?
The
You
product is minus
flipped
1.
it! Yes! And something else.
Minus.
Oh, you changed the sign.
That's it. Some people say perpendicular lines have opposite reciprocal slopes. Have you heard that before? Or my teacher told me, perpendicular lines have negative reciprocal slopes, right? But you flip it, oh, that was good. And then you change the sign. Because one's positive, one's negative. So if you did a problem, you got the tangent line. Answer is letter A, tangent line. Then they go, part B, now find the equation of the normal line. I didn't want you to think like, oh, I got so much more work to do. Just go back, take your slope you found at that point, and do what? And change the what? Change the sign. Does that make sense? We can do it with our problem. Sound good? All right, give it a shot. And when y equals e to the 2x times cosine pi x. Look at that thing. Let me squeeze that cosine pi x next. Letter A. And when did you find the equation of the tangent line? Drawn to the curve. At, now I gotta give you a point, don't I?
Mhm.
Let me make something up. I'm gonna think of something simple and then I'll get your question. How about x equals 0? So if x equals 0, well, let's plug that in. Everyone, what's e to a 0 power?
1.
1. What's the cosine of 0?
1.
Cosine of 0 is 1, right?
Mhm.
So at x equals 0, you get 1 times 1, which is 1.
You have pi x, so that should become 0.
So that's right. So cosine of pi times 0 would be cosine of 0, which is still up.
Oh, 1,
One.
yeah, sorry. Yeah.
You agree?
Uh-huh, yeah.
Very good. Now if I said find this at x equal to -1,
That
or at x
should-
equal to 1, this would became -1, this would become e to the 2, right?
Yeah.
So, hey Josephine, question.
He answered it.
That was it?
Yeah.
Oh, cool.
I was wondering if that x was in it was in a subscript or if it was pi times x. I couldn't see the
Yeah, that's pi times x. A lot of times, we do this cosine 2x and 3x and 4x. That has a cosine pi x. All right, that's going to be letter A. And I might as well way down here when I'm going to say, now I want you to find the equation of the normal line. Drawn to the curve, same point. Where is it going to be? At
0 and 1.
0, 1. So have you noticed sometimes they give you x and y, other times they only give you x? If they don't give you x and y, they only give you x, just take x and plug it in what? All that? Cool. I flip-flop. I'll flip-flop. So you're used to it. Sometimes they give you the full x, y ordered pair, right? And other times they just go at x equal to 0. And for you to get that corresponding y, you just plug it in the original, true? Wherever, I already know these answers. Don't they look like this? Both of these. Both my answers will look like this, won't they?
Would the coordinates be given?
A lot of times that coordinate is given. Not every time though. They either do this or they say at x equal to 0. But you would find that other y value by doing what? Just putting it right in there, right? Because it's got to be right in that function. Does that sound good?
If you put in the calculator that
The
equation.
calculator would do that. It would do it nicely, actually. Because the cosine of pi times 0 is a cosine 0, 1. But I still encourage you to use this. It's really not that bad. I'll make it once. We'll leave it up all class, right? Like, there's the unit circle, right?
Mhm.
And I'll do the Charlie Sheen and the Charlie Sheen and the Charlie Sheen and the Charlie Sheen, right? And this is what? 0 radians. This is what? Pi over 2 radians, pi, 3 pi over 2. But look at you and I are like, oh, what's the cosine of 0? There's 0. What's the cosine of 0? Can you see it?
1.
1. But I did want to let you know that calculator will do that. Just make sure you're in radian mode. Make sure you're in radian mode. And I know 0 degrees is 0 radians, but what if you're doing some other thing like pi? What it doesn't do exactly is like the cosine of pi over 3. Or excuse me, the cosine of pi over 6, because that's radical 3 over 2. And the calculator's not going to say radical 3 over 2, is it? What do you got, 1083?
Yeah, 83.
Hey, do you all agree this is the answer?
Mhm.
So what goes here? 1, what goes here?
0.
What goes here?
Same.
You're matrix between the normal and the tangent line? We all said tangent, normal, right? They're still at what point? 0, 1, right? Normal, tangent. All right. So the hard part's the what? Obviously, right on? You go, well, I'm just gonna stop there and turn my test in. You get a couple points there where you're like, man, I need to get that slope. So how do you find slope? Derivative, which is y prime. Now look at that thing. It's the overriding rule I need. I bet you we're gonna have to play around with chain rule, but to start with, do you all notice something? What's in front of the cosine of pi x? That's not a number. That's not a constant. What's in front of cosine of pi x?
E to the 2x.
E to 2x. Looks like we got a product of two functions up there, right? What rule?
Product rule.
Product rule. Overriding rule, right? Okay. Oh, I gotta start with product rule. It's not like, oh, let me just do chain on that, let me just do chain on that and multiply those two answers, right? There are some derivative rules. There's not a million of these, there's just these 4 major rules. We got power rule, got it. Then you got product rule, quotient rule, and then this big time chain rule. We're starting this thing with product rule. So, okay, you're M, and then all this is N. Does that sound good? Now, who knows? Some of you may like to go off to the side of your paper and go, well, my M is e to the 2x, and my N is cosine of pi x. Because you know you can do product rule. And what's M prime? And what's M prime? Because when product rule is, you can say it to me. Go ahead and read it to me. First times derivative of the second plus second times derivative of the first, true? It's M times N prime plus N times M prime, true? But you may go off to the side just to get these so you can fill them in. It's up to you, but when I'm looking around at students, some actually had calculus before and they're like, destroying themselves, like, I just do it in my head right there and I put it in there. You know, it just depends on how you like to stay organized, true?